okay, the Green's theorem, the line integral m dx plus n dy if the curve C travels anticlockwise and forms a closed curve, form a region R, okay, form a region R, then you can use the Green's theorem, okay, which is a double integral del n del x. Mean differentiates coefficient of, okay, dy, mean del x coefficient of dy minus, okay, del m del y dA. So if the question verified, then you have to do left side, right side, so they are, okay, actually same answer. So in this case, okay, the curve C is a square, okay, from the point 0, 1 to 1, 1, mean, okay, x is 0, y is 1. So move to x is 1, y is 1, so it's a square. And then from x is 1, y is 1, okay, x maintain, y move to 2, okay. So C1, C2, C3 is along, keep the point 1 to 2, 2, okay, 2 to 1 to 2 to 0, 2. X is 0, y is 2. So if you, okay, if left hand side, then you have to do curve C1. Okay, let's look at curve C1. Okay, C1, you notice, okay, C1 is actually y equal to 1, right? Look at the coordinate. X, okay, 0 to 1, but y is 1. X is a variable moving from point 0 to 1. That's why I will let x equal to t. Okay, and then x, okay, moving from 0 to 1. That's why t moving from 0 to 1. So is it okay to get the parametric equation for C1? Because you see coordinate, this is xy, right? Xy. Y is constant, which is y equal to 1. X is variable moving from 0 to 1. So that's why I let x equal to t. Okay, let x equal to t. And then x move from 0 to 1. That's why t move from 0 to 1. Okay, that's why you can find dy. dy dt is 1. So dy equal to, dy dt is 0. Because y you don't have the variable t. So dy equal to 0. Dx dt is 1. So dx equal to dt. Okay, then you plug in, okay, the curve C1, the parametric equation for C1 into the line integral here. So, okay, now we do on curve C1 first. X y squared dx plus y over third x squared plus y squared dy. Yeah, just now I forgot to enter the page there. Okay, we do on the curve C1 where x is t. Okay, C1 t move from 0 to 1, so 0 to 1. X is, where is it? Where it go? Hold on. I want to clear oh, the tablet having problem a bit. Okay. Okay. T from 0 to 1, x equal to t. Y is 1, so y squared is 1 lah. Dx equal to dt. So plug in y is 1. X is t, so it's t squared. Y is 1. Dy equal to 0. So this, okay, 0. Okay, that's why this one 0. So it's just left integral t dt, t squared over 2. Plug in, okay, limit 0 to 1, you get the answer is half. Okay, so the line integral on the curve C1, the answer we obtain here is half. Okay, later on, do on the curve C2. Curve C2, you notice x is fixed, x is 1, y move from 1 to 2. So means C2, x is actually 1, you let y equal to t. And then y move from 1 to 2. That's why t move from 1 to 2. So this is on C2. Okay, so I put it here. C2. Okay, you see x is fixed, which is x equal to 1. Y is variable. Y move from the point 1 to 2. That's why t move from the point 1 to 2. Okay. And then you evaluate, okay, the line integral now c change to c1. Okay, the x, y squared, okay. Your x is 1, so dx is 0. dy equal to dt. So you evaluate the line integral x, y squared dx plus y over x squared plus y squared dy. Okay. On C2, t move from 1 to 2. Okay, x is 1, replace x is 1, y is t, so it's 1 t squared lah. X is 1, y is t, so 1 t squared. Dx is 0. So the first integral gone. Okay, replace y is t, x is 1, so you have 1, y is t, so plus t squared, dy is dt. Okay, so this one, if manually integrate, maybe a little bit, you have to use substitution technique, okay, or quickly you can use your scientific calculator. If not, you have to use a substitution technique. Substitute u equal to 1 plus t squared. Okay, because you got time constraint, we directly use calculator quickly. So integrate alpha x divide sub 1 plus alpha x squared. Okay, dx, okay, from 1 to 2. 1 to 2. So you get answer is 0.8219. Okay, so this is C2, and then C3. Okay, observe C3, y is constant. C3, y, okay, y is constant. C3, y equal to 2. X equal to t, because x from 1 to 0. So t from 1 to 0. So again, you do it, okay? On C3, y equal to 2. X equal to t. X move from, okay, back the graph that you draw. X move from 1 to 0. So t also from 1 to 0. Okay, now you evaluate, okay, curve C3, where the line integral is x y squared dx plus y over sub, okay, x squared plus y squared dy. Okay, so
Doctor,
yes,
why the limit is 1 to 0, doctor?
yeah, look at how your curve move anti-clockwise. Here from the point 1 2 go to 0 2. No?
Oh, 2 is constant. Okay, okay,
Yeah.
doctor, understand.
So x from 1 to 0, x equal t. So t 1 to 0. We look at the
So
direction of the curve.
doktor, kalau point tu berubah, so kita buat dia ST lah kan?
Yes.
Kalau point tu
Kekal
constant
dia
macam ni, letak 2 lah.
ya, sebab dia constant, y dia 2. Yang kalau
Okay.
C1 y dia sama dengan 1. C2 kan X dia constant, X dia sama dengan 1.
Okay.
Yang berubah kita letak dia sama dengan T lah.
If doctor, the constant the limit is not constant, for example 1302, how doctor?
The limit not constant. Which one limit not constant?
No. If the question like limit is not constant means how do we determine the limit, doctor?
But no point is constant like this. 1, 3, 2, 4. Okay. So you may sketch it. Okay, this would be the line segment. Let's say X is 1, X is 1, Y is 3. Here. 2. Let's say 4 here. So we assume this is linear. If 2 point, we assume it's a linear. Okay. If linear, okay, this one we already mentioned, okay, in the beginning of, I think, the how to find parametric equation for the line segment. We use this technique, okay. Okay, it's either you get okay, from your linear equation y equal to mx plus c. Find what is the m there. The m is the y 4 minus 3. So 2 minus 1. Then this is x. And then you need to find the c there. Difficult, okay? You don't have the c, the slope here. Then you need to use another formula, y minus k equal to mx minus h. Okay, using how you find the linear equations. So okay, I can take, let's say, y minus the ending point, which is 4. Okay, m is the slope, which is 4 minus 3 divide 2 minus 1. So I choose the h is the ending point, which is 2. So you get this one, y minus 4. Okay, this one, the slope is actually 1. 4 minus 3 is 1. 2 minus 1 is 1. So it's equal to x minus 2, or y equal to x plus 2. You get the equation is y equal to x plus 2. This is using how you find the linear equation technique that you learned in secondary school. Y equal to x plus 2. You can check back. Let's say when x is 2 plus 2, you get y is 4. When x is 1, 1 plus 2, you get 3. So the equation is correct. Okay, this is using the linear, the straight line equation, y minus k equal to mx minus h. Or another, y equal to mx plus c. C is a y, okay, the y-intercept, but in this case you don't have y-intercept, so better you use this formula. Or another technique, this technique, you can extend it to, if you got the, okay, in the 3D space point, mean you got x, y, z point. If you got x, y, z, okay, the linear, okay, mean the straight line equation, this is only for 2 dimension. You got 3 dimension, you can use this technique where you find a vector v. Vector v, the same thing, you take the ending point, component I, okay, x, 2 minus 1, so you have 1i. 4 minus 3, you got, okay, 1j. Meaning you have actually your vector is I plus j. Okay, then the parametric equation for your x takes a x naught plus, okay, this one, how many time of I? 1, okay, 1 time of I, so it's, okay, 1 time t. Okay, x naught, starting point of x is 1, so 1 plus t. Okay, y will be, okay, starting point of y, which is 3. Okay, 1 time of j, so 1t. So this is a parametric equation using the vector, okay, form. Because this technique, you can expand it to 3. Okay, you got the 3 space, mean the coordinate in 3D space. So this one, in this case, x is equal to 1 plus t, y equal to 3 plus t. Okay, if you use another technique, this one, y equal to x plus 2, you may let x equal to t. Okay, and if you use this technique, the t is always from 0 to 1. Okay, and then here x equal to t, then the y equal to t plus 2. Okay, both, you see, different parametric equation, but you can always prove the, okay, as long as the same curve, same starting and ending point, you should get the same answer. You can check it back. Okay, in the beginning of the line I think in the line integral of differential form, we already shows that, okay, the same curve, you may have different parametric equation, but the answer must be the same. That's why we said line integral doesn't depend on the parametric equations. Okay, so
Okay,
this
doctor,
one,
understand.
if
Thank
the,
you.
okay, it mean you don't have the constant point like this one, because this one you have c, you see y is 2. Okay, so y is constant, that's why we fix y is 2. X move from 1 to 0, that's why t move from 1 to 0. Okay, if your point, you don't have whether x is constant or y is constant, okay, then normally, okay, we connect it, we take a linear graph, then you can either use this technique, y minus k equal to mx minus h, to get the linear equation. Then you can always let x equal to t. Or you can use a vector technique. Okay, both, okay, look like different, okay, parametric equation, but they will get the same line integral answer. Okay, and then so this one, curve C3, y is 2, x is t, x move from 1 to 0, so t move from 1 to 0. Then you plug in, so x is t, so y is t 2, so 2 squared is 4, so you have 4t. Okay, dx equal to dt, t from 1 to 0. Okay, y is 2, replace. Okay, x is t, so t squared, y squared is 4, dy 0. Okay, so this one gone. So it's just, okay, 4t dt. So you get 2t squared divided by 2, 1 to 0. So you have 2 times 0 minus 2. The answer is negative 2. C3 answer is negative 2. C3 we get answer is negative 2. Okay, and C2 just now is 0.8219. Mean later on you have to add up this answer, half plus 0.8219, add up with minus 2, and then you need to find C4. Okay, C4 move from 0, 2 to 0, 1. So mean x is constant, where x equals 0. Okay, y equal t. Y from 2 to 1. That's why t from 2 to 1. Okay, so those have class, okay, you can leave, and then I will, okay, continue record it, then you can watch it later. So the C4, curve C4, x equal to 0, y equal to t, t from 2 to 1. Okay, t from 2 to 1, and then evaluate it on the curve C4, where the line integral, you have the x, okay, you have the x, y squared plus y over third x squared plus y squared dy. So those who have class, you, okay, you want to leave, you may leave. So plug in x is 0. So when you plug in x0 here, the first term 0, xy squared dx. x0, of course, dx 0. dy equal to dt. T from 2 to 1. First term because x0. Okay, so y is t. Okay, x is 0, so y squared, we have t squared. dy is dt. Okay, I will quickly evaluate this one using calculator. Okay, same thing. So okay, x divide by or actually third t squared is t. So t and t cancel actually because x is 0, you have actually sub t squared is t and t cancel, you have actually only dt. Answer is t from 1 to 2. So you got 1 minus 2, which is -1. Okay, you can check. This is sub alpha x from 2 to 1. Oh, sorry. Sub alpha x squared. So the answer is -1. So C4, we get the answer is -1. Okay, C4 answer is -1. Okay, now we add up, okay, all the answer. So the C, okay, x y squared dx plus y over sub x squared plus y squared dy. Okay, you have to do along C1 plus along C2 plus along C3 plus along C4. Okay, C1 we obtain C1 just now -2. C1 is -2. Okay, C2 just now got the floating point. Okay, 0.8219. Okay, C3 we obtain answer is -2. C4 is -1. C4 -1. Okay, we try to add up. Okay, so -2, -1, so it's total -5.
Doctor,
Yes.
C1 is not 1 over 2.
Oh, 1 or 2. Okay. Oh, okay, okay. C1 is 1 over 2. Thank you. So C1 is 1 over 2. Okay. So you got 0.5 plus 0.8219. Okay, total is -3. So -1.6781. 6781. I try to check whether we get correctly without using the Green's theorem. I check the answer given. Okay, the answer they give in this form. Let me check it. Sub 5 minus sub 2 minus 2.5. -1.6781. Is it correct? Yeah.
Yes, doctor.
Yeah, so this is without using Green's theorem. You see, so troublesome. You need to do it 4 times. Do it 4 times. Since okay, the curve travels anti-clockwise, and it's closed, it's formed the region R, then we can use okay, the double integral. Okay, then this okay, this one, instead of doing 4 times, you can just use Green's theorems. Okay, become double integral, okay, across region R. Then this is del x, del x coefficient of dy. Okay, del x, y over sub x squared plus y squared minus del y coefficient of dx, which is x y squared. Okay, and then outside you have dA. Okay, then do the partial derivative first. Okay, when you delta x, y is constant. So delta x y over sub x squared, you can have this is y. Okay, then this one, okay, how you delta, okay, this is Okay, you may have a bit do it other place for you to see. Okay, how you del x. Okay, del x y over third x squared plus y squared. Okay, when the delta x y is constant, you factor out y, and then you delta x. Okay, square root become x squared plus y squared. Okay, power negative half. Okay, you have y. So for differentiation, you bring the power in front. Okay, and then x squared plus y squared. For differentiation power minus half, you minus 1. So it's minus 3 over 2. And then you need to delta x squared plus y squared. Okay, so you got negative y over 2. Okay, then this is a x squared plus y squared power negative 3 over 2. Delta x squared plus y squared, you got 2x. Okay, so the answer you have negative xy. Negative xy, this one you can break it become x squared plus y squared square root and then power 3, something like this. Because you bring down this x squared plus y squared power 3 over 2 is square root power 3. So your delta x answer is negative xy over third x squared plus y squared power 3. Wow. Why they are okay. Later on, delta y xy squared, you got the answer negative 2x y dA. Okay, then dA, you notice, okay, this is a squared, okay, squared. You can use rectangular region. Okay, you can use a rectangular region where y is actually from 1 to y is from 1 to 2, x from 0 to 1, means the y uh you see the coordinate x move from 0 to 1, and then y from 1 to 2. Okay, so you can use Cartesian coordinate. You want dx or dy, doesn't matter, because rectangular region. So you use a dy dx. So you change this one, integrate. Let's say y from 1 to 2, x from 0 to 1, negative xy, so x squared plus y squared power 3 minus 2xy, dy dx. Oh, so a bit difficult to integrate. So it's a little bit difficult to integrate this one because you got this one. When you integrate respect to y, x is constant, but you got this kind of integral. Okay, we can quickly let's say check using mapper whether we can get the same answer with what we do it manually. Okay. Want to integrate what? X 0 to 1, y 1 to 2. Okay, but this integral minus xy. Okay, minus xy divide set x squared plus y squared, and then this is power 3. Got here. Minus xy divided by set x squared plus y squared power 3 minus 2xy. Minus 2 times x times y.
Doctor, the limit is 2, doctor, 1 to 2.
1 to 2. No, this is how they this answer negative 2.5 and then minus, okay, minus 2.5 minus 2.5 plus set 5 minus set 2 plus set 5 minus set 2. Okay, this is directly using the mapper. Okay, if used manually, okay, later I will stop the video and then I find a way, okay, how to, okay, if you want to do manually a bit difficult. Integrate respect to y, here x constant, quite difficult to integrate manually for this one. Okay, to integrate the first term here, the first term negative xy, the third x squared plus y squared power 3, I bring up become x squared plus y squared power negative 3 over 2 minus 2xy dy. When integrate respect to y, okay, negative x is constant here. And then we can, if integrate manually, you may use a substitution technique. Substitute u equal to x squared plus y squared. So du, you got 2y dy. So you notice, okay, the term you have here, the term y dy. Y dy you can replace by du over 2. So the integral, okay, I factor out negative x. So y, I can put out, this is a x squared plus y squared power negative 3 over 2. So y dy is equal to negative x. So x squared plus y squared is u power negative 3 over 2. Y dy is du over 2. So you got negative x over 2. Integrate u power negative 3 over 2 du. So integration, the power will increase by 1. So negative 3 over 2 plus 1, you got negative half. Divide by the increased power, negative half. Okay, then here 2, okay, and this half cancel, negative cancel. You get the answer is x. Replace back u is actually x squared plus y squared power negative half. So mean the first term, the result you have is x squared plus y squared power negative half. So integrate negative 2xy respect to y, you got negative, okay, 2x, so y squared over 2. Okay, put out limit for y is 1 to 2. So 2 and 2 here cancel. So lastly, integrate respect to x. So we integrate respect to y, plug in, okay, limit into y. So you got x, this is x squared, okay, y is 2 plus 2 power 2, this is 4. So plug in into y, so this is 4x. Okay, this one is upper limit, okay, deduct, okay, lower limit, okay, plug in y is 1, so you got x, so x squared plus 1 power negative half. Okay, and then minus y is 1, so minus 1x. Okay, integrate respect to x. So we simplify it, and And then lastly, you may use, okay, again, if you want manual, then substitution technique, let u equal to x squared plus 4, or else, okay, you can, the last integral, because it's a constant, you can use a calculator to obtain the answer. So you got x, okay, x squared plus 4 power negative half. So minus 4x plus x, so minus 3x, okay, minus x squared plus 1 power negative half. Okay, total is dx. Okay, if you're interested to integrate manually, follow the same technique. Let's get the u equal to x squared plus 4. Use substitution technique, let u equal to x squared plus 4. Okay, so here we use, okay, directly the calculator. Okay, I will change this one to square root, and or this one I will prefer this form, x over third, okay, x squared plus 4 minus 3x minus x over third x squared plus 1 dx. Okay, alpha x, okay, divide third, okay, alpha x squared plus 4, and then minus 3 alpha x, uh, uh, this is 1, this is 0, still left out one more term. So minus, okay, here, alpha x divide third alpha x squared, this is plus 1. Okay, you get answer negative 1.6781. Negative 1.6781, okay, which is tally back, okay, what, this one. Okay, this is directly, okay, put out this double integral into mapper, okay, or just now we evaluate it without using line Green's theorem, we get negative 1.6781. Yeah, okay, up to this one, okay, I didn't do it manually. If you want to do it manually, then you have to use, okay, here, if the integral you interested, okay, how to, okay, do it manually, you may let, okay, u equal to, okay, manually let u equal to x squared plus 4. So du will be 2x, okay, dx. So you got the term x dx will be du over 2. Du over 2 is the x dx. Okay, and then the integral x over third x squared plus 4 dx, okay, will become x dx is actually the, okay, half of okay, you have here x squared plus 4 is u, so you have 1 over, okay, u power half du. Okay, this is integrate manually using substitution technique. Mean the x dx, okay, x dx is du over 2. So third x squared plus 4 is, okay, where the u is x squared plus 4, so u power half. Okay, then you integrate u power negative half du. You get, okay, for integration negative half plus 1, so mean you got u power half divide by half du. So 2 and this one cancel. Your answer is, okay, u power half, where the u is actually the x squared plus 4. okay, power half. So mean if do it manually, you have, okay, it's actually you get x, okay, the first integral, the result is actually x squared plus 4. Hanging. The table is hanging, sorry. Okay, mean if do it manually, okay, the first, okay, term you will get okay, third, how do we, okay, mean do it manually, the first term you will get third x squared plus 4. Integrate negative 3x, you get negative 3x squared over 2. Okay, similarly for, okay, the third integral, let u equal to x squared plus 1. So du will be 2x dx. So the, okay, du over 2 will be the x dx. That's why the integral x over third x squared plus 1 dx, okay, you will become x dx is du. Okay, I want to delete. You cannot. Yeah, mine. The tablet is hanging. Okay, x dx is half of du. X squared plus 1 is a u. So you got third u. So it's half. Integrate u power negative half du. So similarly, you will get this one is half. For integration, negative half plus 1. So you got, okay, u power half, divide by half. So this one cancel. So you get the answer is u power half, where the u is x squared plus 1 power half, okay, or third x squared plus 1. So mean the first term you get third x squared plus 4, the third term negative x squared over 2, this is, okay, minus third x squared plus 1. So evaluate from 0 to 1. Okay, evaluate 0 from 1. Okay, you can also use a calculator. Okay, key in here third alpha x squared plus 4, because I got no space to write. Okay, so minus 3, this is 2 alpha x squared, and then minus third alpha x squared plus 1. Okay, calculate. Okay, I key in this function. I want to, okay, evaluate at x equal to 1. So I get the answer. Where's my calculator? Okay, when answer negative 0.6781. Okay, I get negative 0.6781. Okay, and then you have to evaluate it when x equal to 0. So I calculate again. Now evaluate it for the lower limit, which is x equal to 0. So minus 1. So that's why total is negative 1.6781. Okay, because I got no space, that's why this one, I key in this function into the calculator and then press calculate. So calculate 1. So this is the answer for the upper limit just now, upper limit. And then I press, okay, calculate again, press 0. So this is a, okay, answer for lower limit minus 1. So minus 0.6781 minus 1, total is negative 1.6781. Okay, this is integrate everything manually. Okay, initially we shows okay at where okay, this one. Okay, we got this one negative xy. Okay, set x squared plus y squared power 3 outside. So you change okay this one, this line okay directly using mapper. This one okay this line directly using mapper, the answer okay in this form. Change the floating point negative 1.6781. Okay, mean direct from mapper negative 1.6781. Okay, and then if you want to integrate manually, okay, then replace x squared plus y squared as u. Okay, then you obtain the answer is negative xy x squared plus y squared power negative 3 over 2. Okay, so here I one more time. So du is 2y dy because you want to integrate the respect to y. That's why you differentiate respect to y. So the term y dy will become du over 2. So y dy replaced by du over 2. X squared plus y squared is u power negative 3 over 2. Okay, here when integrate respect to y, negative x is constant, factor out negative x. So integrate u power negative 3 over 2. Integration, you index plus 1. So plus 2 over 2, so my left, okay, minus half. So divide by the increased power, which is minus half. Negative and negative cancel. 2, okay, cancel with 1 over 2. So you left x squared plus y squared power negative half. Okay, power negative half. Power negative half. This one power negative half. Okay, integrate negative 2xy, you got negative x y squared over 2. Okay, and then plug in the upper limit. So you integrate respect to y, plug in into variable y. So this is y squared, this is 4. So minus 4x minus, okay, substitution or lower limit where y is 1. So this plus 1. Okay, y is 1. So minus x. Simplify negative x plus x. So total minus 3x. So this is okay x time x squared plus 4 power negative half. Okay, I'll change to this form. Okay, change to over square root x squared plus 4. So minus 3x minus x over third. Okay, x squared plus 1. Okay, you may directly using calculator. Okay, this one from calculator. From this line, okay, I may directly use calculator. In the outer integral, because okay, the limit is constant, you may directly use calculator. Or if you want to integrate manually, then again use substitution technique, u equal to x squared plus 4. So du 2x dx, because you want to integrate respect to x, so you differentiate respect to x. The term x dx become du over 2. So x dx du over 2. Replace back x squared plus 4 is u. So this is u power half. Okay, u power half. So it's integrate u power negative half. For integration, power plus 1. So negative half plus 1 become okay, u power half. Divide by the increased power. So you left u power half where the u is x squared plus 4. Okay, the third integral, same form, is only 4 change to 1. That's why the answer you get third x squared plus 1. Okay, and then here I got no space to show manually. So I key in this one. Third, okay, x squared plus 1 minus 3 over 2 x squared, and then I calculate. When I calculate 0, the answer, okay, 1. Because in minus with lower limit substitution with x0 is 1. Okay, you calculate, put it x1, negative 0.6781 minus 1, so negative 1.6781. Okay, so you see, okay, you can either this part using calculator, okay, or you want integrate manually, or this is from Mapper, and it is proof that we have verified the Green's theorem because we use a Green's theorem, and without using Green's theorem we obtain the same answer. Okay, so with this, thank you for your attention.